My name is Alana Witt, and I'm about to tell you where all the bees are going. The human race is finally waking up. We're starting to realize the consequences of our actions, specifically in regards to the massive amounts of pesticides and insecticides we are spraying in North America on our food. This has been linked to a global decline in world bee populations for the past few years. You might be asking yourself, why are bees so important? Well, the most important thing that bees do is they pollinate. Bees are the crown jewel of pollinators. Specifically, they pollinate flower-bearing plants. Bees and plants exist in a mutualistic partnership. Bees make more flowers by cross-pollination, which in turn makes more food produced from those plants. And, as a human, a large part of our diets consists of flower-based foods, and these foods can only develop upon pollination from bees. Here are some foods that will disappear along with the bees. So, as you can see, as a consumer, you too would be affected by a loss of the bees in your produce choices and the items that you can find around your grocery store. So, what is killing the bees? Well, it's humans. Neonics are an emerging popular preventative pesticide that we are either spraying over crops or coating on plant seeds, before there's even a pest problem, according to the industry. After the crops are treated with these pesticides, plants absorb and transport them to all parts: leaves, flowers, pollen, nectar, you name it. The pesticides are then picked up by insects like bees, and these pollinators are heavily affected by pesticides.
Not the bees! Not the bees! Ah!
Yes, Nick Gage, the bees. Exposure to these neonics are found to be causing problems with navigation, spatial awareness, learning capabilities, food collection and searching for food, disease resistance, and reproduction. You can see why this is a problem. The significant losses of honeybees is a result of a phenomenon known as colony collapse disorder, or CCD. Recent scientific findings have linked CCD to exposure of neonicotinoids and is leading the way towards new regulatory control. Neonicotinoids are the world's most widely used insecticide. They represent 40% of the insecticide market. In 2011, global sales were estimated at more than $2.79 billion. The latest results from a recent Harvard study indicate further proof of the danger of neonicotinoids and also replicate earlier findings from a previous study conducted on the same subject matter. For this study, researchers examined 18 bee colonies at 3 different apiaries over a period of 12 months. 4 colonies at each apiary were regularly treated by realistic doses of neonicotinoid pesticides. Pesticides were introduced into the colonies by feeding the bees with either high fructose corn syrup or sugar water treated with pesticides. A total of 6 hives at each apiary were left untreated, the control group. Of the 12 hives, in total, treated with the pesticides, 6 were completely wiped out.
It's pressure in my day. This life, well, it's slipping right through my hand. These days turned out nothing like
Now let's keep in mind that the dosage that the bees received was not lethal. In other words, the dosage was below the LD50 for neonicotinoids clothianidin and imidacloprid. These sublethal exposures are meant to replicate the exposures the bees would meet in a natural setting. The results from this in-depth study show equal progression of the control and neonicotinoid treated groups. Acute mortality in either group was not displayed during spring, summer, or fall months. The arrival of winter, however, kicks things into 12th gear.
Winter is coming.
As temperatures decline in late October, we observed a steady decline of bees in both the control and neonicotinoid treated colonies, a natural response that we would expect to see. The rise in mortality rate was rapidly reversed in the control, as expected. However, neonic-treated bee colonies continued to die off with an increasing mortality rate, and exhibited symptoms consistent with colony collapse disorder. As it turns out, colony collapse disorder often occurs during the winter season. The sublethal exposure to neonicotinoid pesticides coincides with this. Something of interest to take note of in this study was the abandonment of hives. This is a key symptom of colony collapse disorder. Bees from colonies treated with pesticides completely abandon their hives at all apiaries. This allows us to link the exposed bees to colony collapse disorder with some confidence. We can rule out pathogen infestation as the cause of death because hive abandonment is uncharacteristic under these conditions. So, why are pest-treated bees unable to renew brood rearing towards the end of winter? While there are still uncertainties regarding this, it is hypothesized that the severity of colony collapse disorder, dependent on the exposure to pesticides, might be indirectly mediated by winter temperatures. We think this because of one particularly gruesome, long, dark winter. It was 2010, turning 2011, and the mortality rate spiked to 94%. This is a drastic increase from a milder winter during the 2012 winter season with a mortality rate of 50% of its colonies. In the 1940s, the total number of honeybee colonies was at 5 million. Today we stand at 2.5 million, almost half as much as what we had. At the same time, the demand for hives to provide pollination services is continuing to rise. Annual losses from the winters of 2006 to 2011 was an average of 30% per year. If losses continue at a 30% per year rate, it will most certainly threaten the viability of the bee pollination industry. Many bees would not disappear altogether, but the cost of pollination services would rise, and consumers will feel the consequences through higher food costs. Another question raised by this paper is, why do honeybees mysteriously vanish from their nests? In a natural setting, and as exhibited by the control group, bees typically stay in their nests. Pesticide-treated bees, however, vanish, quite possibly due to neurological impairments. More specifically, the pesticides exert their effects on a bee's memory, cognition, and behavior. Environmental policies aren't changing fast enough. What can you do to protect the honeybees? Well, there are a number of steps that you can take to keep the honey flowing.
Turn your yard into a pesticide-free zone. Take the pledge. Display a sign in your yard and show your neighbors how important pesticide-free spaces are.
I'm going organic. Going organic is not only beneficial for my own health, but it also helps to protect the honeybees. Take a stand against hazardous agricultural practices. Stick it to the man. Build biodiversity. It can help the bees. A diverse collection of soil organisms helps plants to grow without need of poisons.
I will remember you. Will you remember me? Don't let your life pass you by.